Landing on Mars is a one-way ticket. This isn't alarmist talk. It's a reality, officially acknowledged by NASA. A round trip to Mars takes about 900 days. What does that mean? You'd be stuck inside a cramped spacecraft for 2.5 years. More unbearable than prison. Even more terrifying, radiation levels on Mars are 20 to 40 times higher than on Earth. With no magnetic field for protection, your body is bombarded by cosmic rays every single day. In just 6 months, the radiation dose you receive equals 1,800 to 3,000 chest X-rays. And that's not even the deadliest part. Mars' gravity is only 38% of Earth's. After 1 year, you'd lose 10% to 20% of your bone calcium and 20% to 30% of your muscle mass. When you return to Earth, you might not even be able to stand. The most absurd part is this: sending a message from Mars back to Earth can take up to 44 minutes for a reply. If there's an oxygen leak or the life support system fails, people on Earth can only watch it live. They can't save you. Even more shocking, Elon Musk plans, before 2050, to send 1 million people to a Mars colony. Many of them may never return. Today, let's take a look at the chilling truths behind humanity's Mars migration plan. So why are humans still so desperate to go to Mars? The answer lies on February 18, 2021, the moment the Perseverance rover successfully landed. NASA chose to land it in Jezero crater, a decision that reshaped our understanding of Mars. Because 3.5 billion years ago, this place was once a massive lake. Orbital satellites revealed that the lake was about 45 kilometers wide and over 250 meters deep. Even more astonishing, on the western side of the lake, there is a well-preserved delta formation. This proves that rivers continuously fed the lake for at least several million years. On Earth, any place with long-lasting liquid water has life. Scientists chose Jezero crater because they were betting on a possibility that if Mars once had life, its fossils would surely be hidden in this ancient lake bed. That gamble paid off in July 2024. Humanity may have discovered signs of life on Mars. In July 2024, inside a rock from Jezero crater, scientists found evidence that electrified the global scientific community. That rock, named Sapphire Canyon, was sampled from a dried-up ancient riverbed. When scientists analyzed the rock using high-resolution cameras, they discovered many strangely colored spots on its surface. Further spectral analysis showed that these spots contain two key minerals, vivianite and pyrite. On Earth, these two minerals almost only appear together. In places with microbial activity, vivianite usually forms when organic matter decomposes. It's commonly found in peat swamps and fossil layers on Earth. Pyrite is even more special. It's a metabolic byproduct of certain anaerobic microorganisms. Of course, rigorous science must rule out every possibility. In theory, under extreme heat or highly acidic conditions, these minerals could also form through inorganic reactions. But here's the key. Scientists conducted detailed analyses of the rock and found no signs of extreme heat or strong acidic environments. So what does that mean? According to Occam's razor, the simplest explanation is usually the correct one. That means these minerals are likely traces left by microbial activity. Even more exciting, the rock is about 2.3 billion years old. That's much later than scientists previously estimated for the extinction of life on Mars, suggesting that Mars' habitable conditions may have lasted far longer than we thought. So how did Mars go from a habitable world into a dead, barren wasteland? To understand this, we need to go back 3.6 billion years. Back then, Mars was very similar to Earth today. It had a thick atmosphere, mainly composed of carbon dioxide and nitrogen. Its atmospheric pressure was close to half on the Martian surface. Temperatures fluctuated between -20 degrees Celsius and +20 degrees Celsius, allowing liquid water to exist stably. By analyzing Martian meteorites, scientists discovered that Mars once had a powerful global magnetic field, about 20% the strength of Earth's current magnetic field. This magnetic field acted like a protective shield, blocking the direct impact of the solar wind. But around 3.2 billion years ago, disaster struck. Mars' core began to cool, and the molten liquid iron solidified. Without the flow of liquid iron, a magnetic field could no longer be generated. Within a few million years, Mars' magnetic field rapidly weakened, and eventually disappeared completely. After losing magnetic protection, the solar wind began striking Mars' atmosphere. Vast numbers of atmospheric molecules were stripped away and blown into space. This process continued for hundreds of millions of years. Mars' atmosphere grew thinner and thinner. NASA's MAVEN probe, found through continuous observations from 2015 to 2023, that even today, Mars is still losing about 100 grams of atmospheric material every second. Over the span of billions of years, this loss is catastrophic. Once atmospheric pressure dropped below a critical threshold, liquid water could no longer exist. All lakes and rivers rapidly evaporated or froze. Water vapor was blown into space by the solar wind, and ice slowly sublimated and vanished. Eventually, Mars became what we see today, with atmospheric pressure only 0.6% of Earth's, an average temperature of -63 degrees Celsius, and a desolate, lifeless surface. Could Earth follow the same path as Mars? That's a deeply unsettling question. By monitoring global geomagnetic stations, scientists have found that Earth's magnetic field has shown a clear decline over the past 180 years. In the South Atlantic, there is a unique region scientists call the South Atlantic anomaly. In this area, the magnetic field is only about 60% of normal. Worse still, this weak field region is expanding year by year. Satellites passing through it often malfunction, because cosmic rays can more easily penetrate the magnetic shield and strike electronic components. Each time the International Space Station passes through this region, astronauts receive noticeably higher radiation doses. Even more worrying, studies of paleomagnetic records show that Earth's magnetic field fully reverses. On average, every 200,000 to 300,000 years, the North and South poles swap places. The last reversal occurred 780,000 years ago. Based on this cycle, the next reversal is already overdue. During a magnetic reversal, the field strength drops dramatically, possibly to just 10% of normal. This process can last thousands of years. Although Earth would not completely lose its magnetic field like Mars, the impact on human civilization would still be enormous. Satellite systems could fail. Communications could be disrupted. And atmospheric erosion by the solar wind would intensify. That's why studying Mars is so important to us. Mars is not the future. Mars is a mirror of Earth, reflecting the risks we may one day face. Life may still exist beneath Mars' surface. In July 2018, the European Space Agency's Mars Express probe reported a stunning discovery. 15 kilometers beneath Mars' south polar region, radar detected a massive underground lake of liquid water. The lake is about 20 kilometers long, with an area equivalent to 100 soccer fields. More importantly, this is not ice, it is genuine liquid water. You might ask, with Mars' surface so cold, why hasn't the underground water frozen? Scientists believe this underground lake contains extremely high concentrations of salt, mainly saltwater has a much lower freezing point than pure water, and even at -70 degrees Celsius, it can remain liquid. Beneath Mars' surface, due to geothermal heat, temperatures are far higher than on the surface. In polar regions, they may reach around -30 degrees Celsius. On Earth, wherever there is liquid water, there is life. 3 kilometers beneath the Antarctic ice sheet, scientists discovered a completely isolated ecosystem. The microbes there have evolved independently. For millions of years, Deep within rock layers, thousands of meters underground, scientists have also found microbial communities that survive on geothermal energy. So could Mars' underground lakes also be hiding life? From 2020 to 2024, scientists discovered 3 more similar underground lakes. This suggests that beneath Mars, there may be a complete subsurface water system. If life truly exists there, it may have survived in the dark underground for billions of years, waiting to be discovered by humanity. Humanity's Mars plans are accelerating. In October 2024, NASA released its latest Mars exploration roadmap. According to the plan, in 2026, the European Space Agency and ExoMars rover will land on Mars carrying a drill. It can drill down to meters to collect samples, searching for possible subsurface microbes. In 2028, NASA's Mars Sample Return Mission, Phase 1, will begin. A dedicated lander will touch down in Jezero Crater, collecting all the samples gathered by Perseverance. They will then be launched by rocket into Mars orbit. In 2030, an uncrewed spacecraft in Mars orbit will receive the samples and return them to Earth. This will mark humanity's first time bringing samples back from another planet. SpaceX's plans are even more ambitious. Musk announced that the first uncrewed Mars landing test will take place in 2026. If successful, the first astronauts will be sent to Mars in 2028. The goal is to establish, before 2050, a self-sustaining Mars base capable of housing 1 million people. It sounds like science fiction, but technological breakthroughs are accelerating. Starship's reusability has already been proven, and technologies to convert Martian subsurface ice into oxygen and rocket fuel are now mature. What's lacking now is not technology, but sufficient funding and determination. Why must humanity become a multi-planet species? It's not just about avoiding disasters on Earth, but about the long-term survival of human civilization. Over the past 4.6 billion years, Earth has experienced 5 mass extinctions. The most recent one was the asteroid impact 66 million years ago, which wiped out the dinosaurs. Scientists estimate that asteroids larger than 10 kilometers in diameter hit Earth roughly once every 100 million years. Beyond asteroids, there are supervolcanic eruptions, supernova explosions, gamma-ray bursts, and countless other threats. Any one of these could destroy human civilization. But if humanity establishes an independent colony on Mars, even if Earth suffers catastrophe, human civilization will not vanish completely. Humans on Mars could preserve our knowledge, culture, and technology, waiting for Earth to recover, or pressing onward to even more distant stars. More importantly, the process of exploring Mars will spark countless technological breakthroughs: life support systems, radiation shielding, closed-loop energy ecosystems, and artificial intelligence, all of which will eventually benefit Earth, improving life for everyone. As for those who choose to go to Mars, when the Mars One project announced recruitment of the first Mars settlers in 2013, 200,000 people worldwide signed up, although the project ultimately collapsed due to funding issues. The stories of those applicants were deeply moving. A 78-year-old retired engineer said, "The greatest regret of my life is not being able to see humans land on Mars with my own eyes. If given the chance, even if I could live on Mars for just one day, I would still go." A 32-year-old female doctor said, "I know going to Mars may mean never coming back, but contributing to the future of human civilization matters more than anything else." These people are not crazy. They are true pioneers. Just like those explorers 500 years ago who risked their lives to sail toward new continents. They understood the risks, yet chose to move forward anyway. Every leap in human civilization has been driven by people willing to take risks. Without them, we might still be living in caves today. Knowing nothing about the stars, Mars is a mirror for humanity. and also a symbol of hope as Perseverance slowly traverses the Martian surface. Every image it sends back, every data point tells a story about life, civilization, and the future. Mars teaches us that even a planet with oceans, an atmosphere, and a magnetic field can become a wasteland within a few 100 million years. It warns us to cherish Earth and protect the only home humanity currently has. But Mars also gives us hope. The minerals hidden in rocks, the lakes buried underground, all tell us that life is tougher than we imagine, and the universe more wondrous than we think. Perhaps in the near future, when the first humans build a base on Mars, plant the first seed, and breathe oxygen they produce themselves, they will look up at that blue planet glowing in the night sky and realize that humanity, it is no longer confined to a single world. Our journey is toward the stars and the cosmic ocean, and Mars is only the first stop.